Begin monitor. But before we begin monitoring, we need to know what we are going to monitor, right? So if you look here, not here, this is an application. I'm gonna copy this image and bring it here. Okay. And I'm gonna rotate. Where's rotate, 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 rotate? Oh, it's a rotate. Edit view. Rotate, rotate. What the hell is rotate? Hold on, rotate here. I'm gonna do it like this. There we go. Do it the old school way. Back a little bit that way. The mouse. Uh, oh, anyway, let's just do the basic things. So a commercial application like Amazon.com, it's a e-commerce application, right? On Amazon.com, you're able to buy things, shop, right? But Amazon.com has Prime Video, Amazon Music, Alexa, all these other things on here. So it's more like a platform. It's not just a website. It's more like a platform where you can do many things on there. So from that, but behind this application is made up of many things, and that's what I want to teach today, right? Architecting 101. So this application is made up of it's hosted in AWS, right? It's hosted in AWS, and this application is in AWS, so you're gonna have an AWS account. This is the AWS account, the one that you guys created, right? This is the account, right? And in the AWS account, you're gonna have a network. The network is called AWS VPC. VPC. Let's see, VPC. Uh, First of all, you're gonna have a region, right? A region. So you're gonna have a region. So this is US East region. Is it too small? Can you guys see my screen? Can you guys see? Make it a little bit bigger.
It's small.
Yeah, I'm gonna make it bigger. And then for high availability, we're gonna have two regions like that. All right. So you have US East 1A, and then you have US East 1B, right? For higher availability, that's how we need those. Right. All right. And then now that we have those regions, um, we're gonna have a public subnet, which is a public, nothing but a public IP, right?
Dubo, I have a question, please.
Go ahead.
Please, can you expatiate a little bit about this subnet? Because I tried to follow a video there, but I
A
didn't get.
subnet is simply a network. A subnet is simply uh, a piece within your network. So in your house, You have a Wi-Fi. Your Wi-Fi is not open to the public. So your Wi-Fi in your house is a private subnet. If you go to Starbucks, the Wi-Fi is open to the public. That's a public subnet. That's all it is. Simple as that. If it's public, it's a public subnet. If it's private, it's a private subnet. That's all it is. Simple as that. And I'll explain why we have a public subnet here. Okay. But this is an interview question. What I'm doing right now is an interview question. They don't ask you guys, they ask for it's for DevOps, right? They're not gonna ask you this in the bed. It's good to know that you know what DevOps guys do. What I'm trying to do here is that we're gonna design this, then we're gonna go implement it, and then we're gonna monitor it. So we have something to monitor. You can't just monitor whatever, right? You have something to monitor. Now I'm gonna take a private subnet. It's a private subnet down here. We're gonna be good, guys. Trust me. When you leave this class, you're gonna be way, 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 way better than you got here. And hopefully you get a job that pays you at least 170, 180, 200K. And then you can go help others, right? I was telling somebody today, like, guys, don't try to help another person get into the cloud SRE when you haven't got into it. The people who give you the most advice are people who haven't done it themselves. Only take advice from someone who has done it, guys. I'm telling you, please only take advice from someone who has done it. Do not take advice from someone who hasn't done it themselves. Trust me, guys. Experience is the best teacher. No matter how old the person is, wise the person is, if he hasn't done it himself, don't take his advice. All my mentors, they have done it for many years, and before so they can advise me. If you haven't done it, you cannot advise me. Don't waste your time. Okay? That's a life lesson. I'm just giving that. ELB. You need a load balancer, right? AWS load balancer. Where is it? Yeah, load balancer. Load balancer sits here. Right in the middle. This is architecting 101 for those who want to become architects. Okay. Let me push this to the side. I don't need this. Okay, delete that. Okay. Almost done here. So this is just the network. I'm going to list out the design principles when designing an application. And the reason why we'll have this networking structure. So here are the design principles. Follow design principles. When designing an application, you need to follow these principles. I'm saying this because you're going to work with architects and everything, right? So, number one, you have security. Security. And when it comes to security, what are the types of security that exist? You have account security. Account security. I'll give you guys this diagram, right? You don't need to write it down. You have user security. You have data security. You have network security. What other type of security exists? What other security exists, guys? Come on. Anybody? Okay, so that's security. The next design principle that you have networking. Or the network, right? The network is very small. I want to make it 18 characters here. When it comes to the network, what do you have? You have a private network or subnet, private network, public, right? There you have load balancer. Load balancer falls under networking, okay? Because what it routes traffic, right? So it falls under networking. So whenever they ask you, whenever you mention public and private, like what else? What more? You mention load balancer. The next principle, you have storage. If you go for an architect interview, this is what I'll ask you. This is architecting. What type of storage do you have? Database storage. You have object storage. You have data storage. You have backup storage. Okay. What else? Network storage, and then performance. You want an application to perform higher, right? So you're designing for what? High through network throughput, and what else? Low latency. What's latency? What is latency?
Latency. And then you say latency is the amount of time it takes to send a request and respond. Let's see if I don't.
This everybody clap for him. Perfect. The guys putting in work, man. Come on, you guys. You see that. You see it. Come on, you see it. Yeah. You want to design for fault tolerance as well. And I'll explain all these things. Fault tolerance and high resiliency. These are the design tenets. And then we have what we call monitoring and logging. That's where we come in. We come in the monitoring and logging. Monitoring and logging involves what? Logging, log collection, log analysis, sorry. Log analysis, dashboard, monitoring. Okay. So there's some of the design principles, not just some of them. Okay. Not all, but some. Okay. So now we want to design an application on AWS. And the application is going to be called Amazon.com. It's an e-commerce application. All right. What are we going to use for our web server? Okay, I want to use EC2 instances. We know what EC2 instances are, right? Okay. Are we going to have only one EC2? No,
Yeah.
we're gonna have more than one, right?
Yeah.
We're gonna have 4 in there. Web layer. This is a web server layer. We're gonna have a web server here. So this is what? The web server layer, which is what? Which is that Apache layer. That's the layer right there. Okay. Now for our application server, again, we have requests coming in from here. Client trying to connect, right? Gonna connect to either Amazon.com. Traffic goes from here to the load balancer. Load balancer take our traffic and spread it. Oops. Load balancer take our traffic and spread it to, oops. Doesn't want to copy the line. To here, moves the traffic to here. Oh, very sensitive mouse. To here, to here, and then to here, right? And then when you're done browsing on this web server, your Geico.com or Amazon.com, you're browsing, you don't shop. You don't shop. You just hear window shopping, right? Looking at laptops, comparing prices. Like my guy Kobe, just looking at laptops and trying to make a decision on what laptop to buy. Maybe I should go buy on Bedwell.com. I don't know. Just looking at laptops. I'm not gonna buy on Amazon.com. Laptops is two of them expensive one here. I'm just go to Bedwell.com. You know, just browse and then laptop. Okay. Someone else kind of browse and browse and browse. Okay, I'm gonna buy. Okay. When that person buys, their request leave the web server and comes down to the next layer down here. And this is the next layer. We're running our application on EC2 as well. But here, it's dedicated. This is Amazon.com/electronics. It's not just one server running everything. You have electronics. You have Amazon.com/Prime. You have Amazon.com slash music. You have Amazon.com slash, yeah, you have Amazon. Let's see what else Amazon.com have. Prime Music Video, like Fire tablets. Um, they have same day delivery pharmacy, medical care and pharmacy. This Amazon Health, different server on its own. Amazon Health. So you come here, they have Amazon Health. So it's Amazon.com/health. So if Kobe decides to buy a laptop, the traffic will leave the server. Here, there's no demarcation of which server you're on. It's just Amazon.com. All the pages are being served here. There's 7 health, everything is served on this one layer here. Then when you decide to click on electronics and buy a laptop, and you put your credit card information, you submit your order, your request will leave here, come to the load balancer. The load balancer will take your request and spread it. So, okay, you want to buy electronic, I'm going to send it to the electronic server. If someone here wants to buy a medication, you'll go here and the request will leave here and go here, Amazon Health. And if you come here and this person wants to buy Amazon Prime Video, the request comes down here. This is load balancer. And load balancer will look at the request header and say, oh, it's Prime Video, and you send it here. And if this customer here is looking for music, the request will go here. And then load balancer will say, oh, okay, it's music. So I'm going to send his request here. Okay. So this load balancer is what? It's an application load balancer because this is the application layer. This is the application layer. This is the business layer. This is also called a business layer because this is where the business makes its money. It's called a business layer. Application/business layer. This is the business. This is the business money maker here. That's why I'll put in a private subnet. Everything here, private subnet means private IP. Public subnet means public IP. Ayamba, private subnet means
Yeah,
private
got
IP.
it.
Private subnet, private IP. Public subnet, public IP. Okay? And then
Yep.
last but not least, because we need to store people's data long term, we need to have customer accounts. We're going to store the information in a database. So relational database, RDS database. That's the database. And we'll put the database is also in a private subnet because we don't want people's information to be exposed. And here we have a primary database where we'll store their information. Right? And then, but it's since we don't want it to be highly available, we also have a secondary database as well. It's called a standby. This is called a standby database. So that if this primary goes down, the standby becomes a primary. Applications that sell the electronics will store the data here, will store the results or the customer's information here. The customer's order number, all that stuff, will store it here. Okay. Any questions so far? Any questions so far, guys? No? For health, everything that customers buy with health, they will store it here directly, like that. Similar thing, if you buy a Prime Video, it stores it here. You store your order ID, the movies that you're watching, you store all that stuff in here, right? Same thing for music. All your Amazon Music will be stored under your account in the database. And then every data that is stored in this database is also replicated to this standby database. Replication occurs here. In real time, everything stored here replicates here. Replication. This is a one-way traffic though. Um, see what's happening here. Right? One way. And that's your 3-tier. This is a 3-tier web application. 1, 2, 3-tier. So we have then for storage, right? For storage, for the information that does these pictures that you see here, these pictures, all these things, all these pictures like this you see, they are not stored in the database, okay? They are stored in an object storage called Simple Storage Service, S3. They're stored in a bucket like this. It's not in the public subnet. It's out here, okay? The web server reads from those images from this bucket. The web server reads images from that bucket. Guys, don't worry about my lines, okay? I'm just using this to teach. On the job, if you're architecting, you won't be crossing lines like this. There's a better way to do it, but it takes time. Architects spend about 2 weeks to do something like this because it takes time. Okay, so this web servers pull those images. These images that you see here is stored in the storage, object storage. It's an object storage called S3. It's stored in here. Okay, it's stored in here. Any questions so far? Okay, so account security, we're going to secure this account. How are we going to secure the account? Account security. We're going to use multi-factor authentication. And we're going to see it. We're going to see all of this stuff in our notes that we're about to do. Right? Account security, multi-factor authentication. That's two-factor authentication. Do you guys know when you try to log into an account and they text you a code before you log into your account? Has everyone experienced that? That's what account.
Yes.
So let me go show you guys that. Where is it? Let's look at it real quickly. Account security. Right here. So we're going to do IAM, which is Identity Access Management. And account security is this multi-factor authentication. This is your account. You're going to put your username and password. Then they're going to ask you to provide a code from an MFA device. You enter that before you can log. It's called two-factor authorization or authentication. Okay, to ensure absolute security before you can log into the account. That's account security. Okay, for data security, we're going to use key management service, which is to secure our data on the data layer. We're going to use key management service. It's an encryption. We're going to encrypt it. We're going to encrypt the data. So we're going to use key management services here, in this database, and in this bucket, the storage bucket here. We're going to attach encryption to it. So the data is encrypted. What is encryption? Encryption is simply, instead of you seeing, hello, my name is Debo. If this string is encrypted, this is how it looks like. It will look like this. You will not see anything. You won't see anything. Or depending on the type of encryption that you use, when you try to encrypt it, it will not open. Right? It might be like this. You won't see anything because it's encrypted. That's security. Encrypted. What this is? Plain text. Plain text. We'll look at it. We'll look at security. We'll get it. We'll get to that. Okay. I want to just show you guys what this is. Any questions so far? Okay. And then for data security, we'll have KMS as well. For network security, we are already taking care of that by putting our application in a private subnet, and the database is in a private subnet. So we have really protected that network. It's protected. And then this is the database layer. So this is what we're going to be monitoring, guys. This is what we're going to be monitoring. We're going to be monitoring to make sure that the database is up and running. The EC2 instances are running correctly. They have enough CPU and memory so that they don't crash. Because if they crash, guess what? Customers cannot buy on Amazon.com. Any questions? Guys, ask, please. Any questions, guys? Ask a question, please. I want to make sure that the question you ask me will let me know if you understand. Are we understanding this? Can you guys send me online?
I have a question, right? So last time when I was looking at VPCs, I came across this topic called
Why are you looking
engine.
at VPCs?
I think I saw from the note right that you sent.
Yeah, I sent you guys note doesn't mean you should open it and look at it. But I didn't say look at the notes. I said keep the notes, right?
So the question was,
I cannot answer any question on VPCs because I haven't taught VPCs.
okay.
Yeah, I just feel like you need to follow instructions, man. It's very important, man. Right? We just talked about it, right? If you do what you're not told in the job, you're gonna get fired, guys. There's no, if they don't tell you to do anything, don't do anything. Why are you looking at VPCs? You don't know what I'm gonna teach next or this or that, right? Guys, if you're here to learn Cloud SRE, let me teach you. Let me tell you what to study, what not to study. If you have your own idea of what you want to learn, then you shouldn't be here. Let's be clear. I'm not gonna sugarcoat it. After I tell I'm gonna get you a Cloud SRE job, I know what you need to know to get that job. Trust me. I've been doing this for many, many years. If you want to go and start studying your own things, you can study your own things. That's up to you. You're an individual. I cannot answer alleged questions based on that. I didn't teach you VPC. No, I haven't taught that. I'm teaching you three-tier architecture. I'm teaching you that we're going to create an application that looks like this with the load balancer with 4 EC2 instances here for the web server that users are going to be using, right? Users connect to the web server to browse the internet and browse items on Amazon.com. And when they hit place order, their request will leave here and come to the application layer where their request will be served. They can either buy electronics, buy medications for same-day delivery, right? This application will collect their address, collect their credit card number, process it. The application that runs on this layer is called an online processing order application. Online order processing. There are lots of online processing applications out there. Online order processing applications. The most popular one is NetSuite, Oracle NetSuite. That's what they use, right? You have NetSuite, you have what's that thing called? Forgot it. Forget it. You have NetSuite, you have OCR processing. No, not OCR. You have NCR. I think it's NCR. Credit card processing, right? Restaurant payment and credit card processing. So because Amazon.com collects your credit card and process that credit card, NCR runs on this application as well. NCR runs here, and then you have AVI, address verification, address verification application, AVI. So IBM InfoSpec, all this is the IBM verification application. They take this application and install it on this layer. So they install AVI, they install NCR, they install the online order processing all on this layer. And that makes Amazon.com so that we can receive orders, charge your credit card, verify your address, process your order. Then that request goes to the database, stores your order ID in the database, and then the response leaves the database back to the application. The application generates an order ID number, a message that comes back to you on your page that says your order has been placed. Here's your order ID number. And then you get an email notification. So this application also generates emails that goes to your email. But because your email is part in your account, it knows which email to send to you. And then after 2 days of you placing the order on Amazon, there is some AI stuff that runs on this layer as well, based on your order. Then you get an email. It's called a recommendation engine. You get an email that says customers who bought this also bought this. It's Amazon trying to sell to you. It's called upselling. When you buy an item, after 24 hours, they will propose you another item. That customers that bought this also bought this. That's how Amazon makes money. That's the whole application system around it. So we, as cloud SREs, are not going to build this. No, it's already been built. We're joining the company to make sure that this is up and running 24/7. So we're going to be monitoring databases to make sure the databases are up and running. We're going to monitor EC2 instances to make sure they're up and running. Make sure they have enough CPU, they have enough memory, they have enough storage to run. We're going to monitor security, make sure that no subnet, no network is open to the public. We're going to monitor the storage, the FC bucket, make sure no one is accessing it illegally. We're going to monitor the performance to make sure that the performance meet a certain standard. We're going to monitor the latency. Latency is the amount of time it takes to send a request and get a response. When customers click place your order, when customers click place my order, how long does it take before they get their response that says your order has been placed? It has to be below 10 milliseconds. 10 milliseconds is 1 second divided by 10. That's 10 milliseconds. 1 second divided by 10. So 10 milliseconds is how long it will take. Okay? Okay? Any questions there? We have to monitor throughput. How do we monitor throughput? On CloudWatch, you see, it reads when a request goes down, when you want to see your order on Amazon.com, you go to orders, go here, and you click on orders, my orders right here. When you click on that, how long does it take to come back to bring your orders up? That's read throughput. Or how much time, that's read throughput. Resiliency, we'll monitor those things. Also going to collect logs, database logs, application logs, web server logs, collect all those logs, push it into an FC bucket. We're going to call it the logs bucket. And we're going to monitor it. We're going to create a dashboard from it. We're going to see how many users log in to our site per day. The log will show us all that stuff. That's the job of a cloud SRE. So we're going to monitor these things, security, network, storage, performance, monitor the logs, all those things. That's our job. So once we build this application, we know what to monitor. There's a little demo here by this guy called Adrian Cantrell. Adrian Cantrell is this guy here. He used to work at AWS, and then he left and went. He now trains and has his own personal business. He's in Brisbane, Australia. He has some labs that he did create, free labs, and there's simple demos in here. I'm not saying you have to create them. I can create a small application. You can see here there was a small web layer application. This one shows elastic load balancer, stickiness. No, not this one. You don't have to create all these things. I'm looking for, go back here to simple demos. It's somewhere here. I just opened it just now. Labs, it's here. A simple website, right? Right here, this one, right? A simple, you see here, this green is the public subnet where it runs the data, and then this is the application layer, and the database layer. Similar to what we just have here, what we have here. Public, private. Public is the web layer. Private is the private, the application layer. And then here's the database layer. So this is what we're going to be monitoring. Any questions, guys? Any questions? Okay, so that's that, right? So that's that about the design principles. We are going to focus now on learning security network. We've really learned a lot of network. I'll say let's just go ahead and finish out what network is, so we can close that topic out. Okay. I'm not gonna go deep into what networking is because you don't really need to know deep into networking. Our focus is monitoring, so we're gonna stay around monitoring. So we're gonna learn about public, private, and elastic IP addresses. We're gonna learn about subnets and what the VPC is. But we're not gonna go deep in details into these things down here. Okay. So first things first in networking, the OSI model. Does this look familiar?
Yes.
Anyone wants to explain what the OSI model is? That's your interview question. What is the OSI model?
I think is how data move from physical layer to the application layer.
That's not it, man. You want to explain, you have to explain the whole thing.
Oh, you want me to explain where from the physical layer everything that's happened?
Yes, that's how they'll ask you in the interview, man.
Okay. Okay, let me try. Okay. At the physical layer, we got with data living with physical layer before moving to and arrive to a link or no, not to a link layer, to a data link layer, yeah, to a data link layer, and this data is gonna be encrypted with it's gonna be like a binary, yeah, binary format, and move to a network layer where the data will be now it became where the format change is going to be attached with IP address before moving to the transport layer where it will go out of internet now and you arrive into a session layer where you ask where the request will be sent to the server and we ask for credential before moving to the presentation. Once the session starts, yeah, the session starts is moving on to the presentation layer and there will be an encryption of the data at this level at the presentation layer and data will be on the application. It's a little bit, that's all.
Just clap for him. At least he's trying. So yeah, the OSI model is a model where data moves from between systems, right? It's an open systems interconnect model. Data leaves a physical layer, which is your laptop, to a data link layer on your laptop still, which is the MAC address. Remember I talked about the MAC is a physical card. The MAC address card on your laptop is a physical card, right, on your laptop. And these are the protocols on your laptop. This is irrelevant, right? The only protocol that's irrelevant is from the network layer. Data goes on the physical, is on motherboard. This is on your motherboard, on your laptop, on your computer. It's a link layer, right? It links to your MAC address, the data link layer. And then from there, the data link layer links to the network interface card. So another card. But the network layer now it generates an IP address. A MAC address is your physical address on your laptop. A MAC address is a physical address on your laptop. It has a MAC ID number. MAC stands for Media Access Card. Media Access Card. And then the data goes to the network layer. At the network layer, it has a network interface card, a physical network interface card. That network interface card is what has Wi-Fi connected to it. It's what has Wi-Fi connected to it. And when it has Wi-Fi connected to it, it goes out to the internet. And before it goes out to the internet, it needs to grab what? An IP address. An IP address is your logical address of you online on the internet. Without an IP address, you cannot get on the internet. To get on the internet, you need a public IP address because the internet is public. If you're a server and you want to get on the internet, you're gonna get a private IP address. From there, once it goes to the network layer and you have an IP address, which is a logical address of you online, now you can go out to the internet. Data can leave your laptop and go out to the internet. That's where it now goes to the transport layer. What transports your information from your house out to the internet or to another server is the TCP protocol. If you have a public IP, your information is going over TCP protocol because TCP is public, UDP is private. UDP is private. UDP is server to server, peer to peer. And then when it leaves the transport layer, it goes out on the internet. Here, protocols is HTTP, SMTP POP3, FTP. This is now the internet now. This is now the internet. It now hits the application, but before it even hits the application, it makes a connection, right? The client has now connected to the server and it starts transferring information. So a session is created. It hits the session layer. And then because the data is stored in binary operation, it now has to present the data. So it goes to the presentation layer and then it hits the application. That's pretty much it. Simple as that. But when explaining it, you have to explain these protocols. But the most important one is at the network layer, you have an IP. At layer 4, you have TCP. And layer 5, 6, and 7, you have HTTP or the respective protocol. That's it. So VPC stands for Virtual Private Cloud. It's the network structure in which AWS operates, right? This is a VPC here. So it's a region. And then in here you have a VPC, right? VPC. Where's the VPC? Right here. It's a VPC. Right here is a VPC. All of these subnets are inside of a VPC. right? So right here, right? Enter the VPC. We're not going to go too deep into VPC because it's not about AWS. It's not about Azure. It's not about Google Cloud. It's about monitoring these network systems. It could be any system. I have notes on Azure. I have notes on Google Cloud. Let's not focus on VPC alone. Understand that VPC is called virtual network in Azure. VPC is called cloud networking in it's called cloud networking in Google Cloud. Okay. It's not specifically about AWS. It's any network infrastructure. Okay. Any cloud. That's what it is about. Okay. Any questions? Okay. So it's pretty much a network in AWS. That's what virtual cloud is. It's a virtual private cloud where when you open your account, all your resources will be in that virtualization of network, right? You have your own router, you have your own internet inside that box. That's all it is. Simple as that. So a VPC is simply allows you to launch resources, EC2 instances into a virtual network that you define. So you can create your own network within your AWS account, and it resembles traditional network infrastructure like your Wi-Fi at home. It's the same thing. You have a router at home. In this VPC, you have a router as well that you operate. As simple as that. That's what it is. So you can see this is a VPC diagram. This is a VPC. This is your account. And this is your VPC here in this box that you see here. And in this box, you have your EC2 instance and the default subnet here. This subnet has a public IP address, and it also has a private IP address as well. Cancel. And this subnet here has a public IP and a private address. So this is the open subnet, okay? The reason why this subnet has a public IP address is because we are connecting it to the internet. So we have a router that allows us to go out to the internet, and that is a router gateway here. It's called internet gateway. If your router has a route to connect you to the internet, you're going to have an internet gateway. Okay. Any questions so far? So that's an internet gateway route. Because of the internet, you see that this is your router. This is your router. This is your route table, right? This is your router. This route here is what makes it go out to the internet. 0.0.0.0/0 is the internet route. That's what makes this applications, this EC2 here, be able to go out to the internet. The router has a route called internet gateway. It means that when it's an internet gateway, that's why you have a public IP address here. Okay. The next one down, if you see here, if we don't have this gateway, you only have private IP addresses in here. It means that this server can talk to this server using a private IP address. There will be no public IP address involved here. Okay. Okay. Knowledge check. Let's check our knowledge. Amazon VP is a component of which AWS service?
Network.
You're right. networking. Amazon VPC allows you to A, B, C, or D.
D.
Anyone else?
Anything network. I think B also.
B. B.
Okay. I heard you the first time. Yeah, B. Okay. Cool. So a default VPC comes empty with no resources inside of it. It's empty. We have every account has a default VPC. Okay, like that. So, but when you add an internet gateway in the routes, you're gonna have one that is public. And then when you go create an instance in that VPC, it's gonna become a public subnet. And then when you create an instance in here, that instance can be public. It can be public. The only reason it can be public is because if you go open up the ports for public internet to connect to it. So this is a custom VPC. When you create your own VPC, you can customize the IP addresses in that VPC. You can say you want the web servers to live in these subnets, right? The web servers to live in here, to have a 10.0.0/5, 6, and 7 web server, and a public subnet. That means that this subnet will have an internet gateway route, like what we did in our diagram. We have a public subnet up here. That subnet has an internet gateway route table, means it's open to the internet. And then we have a private subnet, which will store our database servers in the private subnet. And this subnet has no access, hold on, to VPN subnet. It has no access to the internet right here, customer gateway, virtual gateway here, VPN. So customers access this to a VPN connection. I'm not gonna go into too much detail, but I want you just to understand how VPNs work. So with VPN, well, our applications are in AWS. We have something called a virtual private gateway, which is where all private connections connect to. So if you're connecting from Dallas, Chicago, whatever, you can connect to a VPN connection, which is a customer gateway over a VPN connection to their account in AWS. Okay. This is not set up by you, set up by SREs. However, your job is to monitor the traffic. What is traffic? The requests and the responses that clients in Los Angeles are sending to AWS. And AWS servers will respond back. So the traffic is going over a VPN network, a VPN channel. And so your job is to monitor that channel. What do you do? How do you monitor a channel? What commands do you run? You guessed it. Where's our Linux cheat sheet? Open recent Linux commands. How do you monitor networking traffic? What do you do? Networking. What is that? These commands. What is that? Dig domain, right? We saw it, guys. Dig geico.com. I always know how many hops, right? Time, the server that is on. This is the MAC address of that server that is on, right? So that's how we do monitor traffic. We're going to have monitoring scripts. The monitoring scripts, monitoring network traffic. We're going to enable VPC flow logs. Detect performance issues, optimize performance, network performance, prevent problems, manage resources. What are the tools? You have Datadog. We have SNMP. We have VPC traffic mirroring and Azure Network Watcher. You have Google Cloud Packet Mirroring. So like I said, it's not all about AWS, right? We'll do the Azure Network Watcher, ANW. We'll look at Azure Cloud Packet Monitor to capture and analyze network traffic in the cloud. What are the tools that they use? You have network monitoring tools here. that we'll look at. But that was just one piece that we're going to look at, right? One piece. If you look at our diagram here, we have 1, 2, 3, 4, 5 things to do. Performance monitoring, storage, networking, security. We need to monitor all these things. So networking is just one of them. And we just saw these are your commands. If you're doing it manually, these are your commands that you have to run to monitor network traffic. That's what I want you to focus on. We're not DevOps engineers. We're not developers. Our job is very specific. Our job is very specific. So all the communication happens between this customer's office and our AWS cloud over special connection. We're going to monitor the traffic. So if someone does anything bad, we can know. Okay. Any questions so far? Any questions so far, guys? Okay. VPC pairing is not very important. What is attached to the VPC by default?
Internet gateway.
By default, every default VPC in AWS has a internet gateway. Every default VPC has an internet gateway. Let me show you guys that. The default VPC or default virtual private cloud is the default network that comes with your account. This is called multi-factor authentication. We're going to set it up at some point. This is authenticator app, can be Google Authenticator or Duo, right? Registering MFA will be required in 14 days' time. They require all accounts to have two-factor authenticator. For now, I'm going to skip it. And if you go to VPC, this is your virtual private cloud. And then you have two. This is a custom one that I created. This is the default one. So the default one, this is the default one. If you look at the route table for the default one, look at the routes, it has a internet gateway because it's the default one. It comes by default. That is the internet gateway. That's it. This is what makes this VPC public. Okay. So how do you create a VPC? It's very simple. You come to services, you go to networking and content delivery. You choose VPC down here, and you create a VPC here. Create VPC, or you can say you want VPC and subnets. So you can say you want a VPC, you want one subnet, one route table. You have two subnets, one route table, right? You can come and choose here. So auto generates, or you can choose your own, right? So like tests. So you can come and choose a CIDR block, which is the network range that you want. You want two subnets, two public, two private IPs. No NAT gateways, one S2 VPC endpoints. And you want to also enable DNS host names. So you're going to give us two public subnets, two private subnets. Okay. You're going to click on create VPC. And it'll create everything for you. That's it. That's how you create a VPC. Okay, that's it. VPC has been created. So if you want to go ahead and study the rest of these documents, go ahead and study the rest of these notes. Okay. Why would you create a custom VPC? Why would you create a custom VPC?
Okay.
Anybody else? Anyone else? Okay. IP addresses. Private IP address is not reachable over the internet. It's used for communication between instances in the same network. So if you have two servers in the same network, it's used to communicate. When you launch a new IP instance, it's given a private IP address and an internal DNS host name that resolves to the private IP address of the instance. Simple as that. That's a private IP address. No connection to the internet. That's it. Public IP is separate from the internet. You can use public IP addresses for communication between your instances like that. And you can use public IP address for communication between your instances and the internet, not between your instances and their internet. Well, I've been to this multiple times, so I'm going to skip that. Elastic IP address is a static public IP address, persistent IP that is allocated to your account and can be associated to and from your instances as required. An elastic IP is a fixed IP. When we restart our servers, when we have an EC2 instance and we restart the server, what happens?
The public
We
IP
get a new
changes.
public.
We get a new public IP, right? So if we bought some licenses, that are attached to a public IP address, and we want to and we don't wonder if we restart the server, the public IP should the license should still be there. What do? We are assigned an elastic IP address so that the software license is tied to that IP address, that elastic IP, so that even when we restart the server, the licenses are still there. How do you create a public IP address, elastic IP address? You go here, go to VPC, and you go to elastic IPs, and you allocate an elastic IP. You cannot create one, you allocate one. You choose your region that you want to create one in, you just click on allocate. And that's it. If I take this IP address now, right? If I go now to my EC2 instances, if I have any running, I can attach that IP to an instance. If I have an instance, I can come in and attach that IP to that instance. If that instance restarts, the IP address will stay the same because it's an elastic IP address. Some customers use it because they don't want to lose their licenses. Okay. So some customers use that. So that's it. Elastic IP address is right there. It's 5.2. That's it. It's static. If I want to delete it, I'll go here and I click on release elastic IP. So what are the cycle IP is? You allocate one, then you associate it with an EC2 instance. Your instances will appear here. You can associate with an instance, or you can associate with a network interface. Choose a network here. You can associate with a network interface or the private IP address. But most of the times, most of an instance. Yeah, then you associate. When you're done associating, you don't want to use it anymore. You come back here, you click on disassociate. After you disassociate it, then you can release it. If it's still associated, you cannot release it. So it's associate to a server, Then when you're done, you disassociate it before you release it. So we're going to release the IP back to the system. I don't have any more IP. Okay? When it's an elastic IP address released from your account, when is it released from your account?
Until you delete it. Option D. Yeah.
I just talked about it.
Option C.
Anybody else?
C.
C.
Yes, you give me an answer after I've shown the answer. Are you even looking at the screen? Come on, man. Focus. I am focus, man. Focus. It remains in your account. You choose to release it.
I say C now.
You say C after I've shown the answer. What are you looking at, man? Focus, man. Focus, man. You need that. You need attention to detail, man. So then it can be assisted with and from your instances. For Elastic IP, you have to release it from your account. Talk about subnets. You have a public subnet and a private subnet. A subnet is simply a range of IP addresses in your VPC, similar to how you have your Wi-Fi at home. And when someone comes to your house and connects, they have their own IP, you have their IP, even though they're in your house. So every house has a list of IPs that you can have. So subnet is pretty much a range of IP addresses that you can have, right? You use a public subnet for resources that you want to connect to the internet, and use a private subnet for resources that won't be connected to the internet, like we did here in this diagram here. We have a public subnet because we want these web servers to connect to the internet so users can come here and browse or shop online. And then back here with a private subnet because we don't want these resources or servers or databases connecting to the internet. We only want it to connect to these instances here, right? Because these instances have a public IP and private IP. The private IP from here talks to this private IP here, but the public IP here talks out to the internet. So it's a two-way traffic. This guy can talk to the internet and talk back here to the load balancer. He talks to the load balancer talks to this web application server. The application server talks to the database. How do they talk to each other? Private IP, private IP. How do this web server here in the public subnet talk to the internet? Public IP. But here, this guy talks to the load balancer. The load balancer can take the traffic and send it to private IP back here. A smart question will be, so what is the load balancer? A public IP or a private IP? What do you think? What's the load balancer?
I think it's a combination of both.
Thank you. It's a combination of both. Thank you. That's the right answer. Load balancer is a combination of both. The load balancer can detect the request and say, okay, the request is going to a private environment, so use the private IP to communicate here. Then when the response comes back, oh, the response is going to the public environment, I'm going to use the public IP to communicate here. So the load balancer is very dynamic. It can change to private communication or public communication. We're not going to go too deep into that. You don't need to know that stuff. You just need to know how to monitor load balancer traffic. Because load balancer traffic is, you need to understand load balancer traffic. Load balancer traffic is a little weird, right? You have to monitor load balancer traffic, right? It's a little weird. We'll do Datadog. We'll do Datadog. We're going to install Datadog monitoring. And you see request counts on the internet. You see how many users are connecting per second. That's load balancer traffic. You see how many requests accepted, how many requests denied. You see all that stuff, right? So if you want to go and start learning Datadog, you have my permission to start learning Datadog. Go to datadog.com and click free and start playing around with it. However, you only have 14 days of monitoring, so I wouldn't use it now unless you have multiple email addresses that you want to play around with. But if you want to learn that dog, go ahead and learn that dog, right? You can monitor traffic on premise. You can also monitor traffic in the cloud. Okay, so but that's that. So you have two subnets, private and public. The public subnet has a range of public IP addresses, while the private subnet has a range of private IP addresses. This is the subnet diagram. This is how it looks. You have a VPC subnet here and down here. This is a private subnet, no connection to the internet. And then this is a public subnet connected to the internet. It's that simple. Demonstrate how to create a public subnet and private subnet. I'm not going to go that deep. You don't need to know that. Then here, a subnet can. What's the answer?
D.
A subnet can be mapped to one availability zone only. Right here. Availability zone. US is 1A. I did it in my diagram as well. Let's go to my diagram. Right here. US is 1A, public subnet, public subnet. US is 1A, private subnet, private subnet. US is 1A, it's right here. So one subnet, one availability zone. That's what the subnet is. Okay. That's that. Internet gateway is a horizontal scale VPC component that allows communication between instances in your VPC and the internet. That's all internet gateway is. It's very simple. Okay, you see right here in your house, you have your laptop, you have your phone, you have your computer, you have your Wi-Fi in your house, and you have a local area network in your house. You have Wi-Fi and you have the local area network in your house. So traffic leaves your phone, your laptop, it goes out through the internet gateway, which is your router. You have a router in your house, right? You have your router in your house. You have the router in your house and traffic goes to that router and traffic goes to that router and it goes out to the wide area network, which is the internet. So you see here, this is the internet gateway diagram. You have a public subnet. US is 1A, private subnet US 1B, and then you have the internet gateway right there. Okay. So that's it. Last question is well above time. Last question. An internet gateway allows what?
B.
Allows communication between the traffic and the internet. Okay, that's it. Cool. I'm gonna give an assignment. I'm gonna give an assignment and it's EC2. This is monitoring. This is not this is what you'll be doing on the job. So I'm gonna give it now. It's AWS CloudWatch logs. I don't know if I should do the country. Where is it? CloudWatch. This one should be very easy. Where is it? CloudWatch, CloudWatch, CloudWatch logs. You guys see here or simple demos? This will be in here. CloudWatch logs. CloudWatch. And that's flow logs. Okay, let's do a very simple one. CloudWatch logs right here. So analyzing logs with CloudWatch logs. Getting started tutorials. Let's do the installation of CloudWatch logs. You can install the agent on a running EC2 instance. This one. Install and configure CloudWatch logs on a running EC2 instance. So the steps. Follow the steps here. Step 2. Follow all the steps. Run these commands. And that's it. That's it. That's the homework. Remember, we get paid to read. So make sure you read this thing that says important. That's the assignment. Should I put it in the chat or email you guys?
The chat.
Okay, I'll put it in the chat and I'll also put it in Slack as well. Assignment. Okay, that's your assignment. Due on Monday, 7 p.m. You can submit it if you want to, you don't have to.